It's my great pleasure to introduce James Pustejovsky. He went to MIT for his undergraduate degree and did math and linguistics. He did Fulbright in Germany in classical linguistics, and went to the University of Massachusetts at Amherst to do his PhD in linguistics. And then did a postdoc with Wendy Leonard and David McDonald in computer science. And he's now a professor of computer science at Brno University. I've known James for about 20 years. His interest is lexical semantics, and he's responsible for the theory of the generative lexicon. But I think he has a very unique perspective in our field, because at the same time that his interest has been in representing meaning, he's never taken his eye off of the big picture like some of us have. He also has always led a big team doing an application. So he was involved with our laboratory in the Tipster project. He's worked in the Equate project recently doing question answering. He's had his own company called Lingo Motors. He's been involved in huge state-funded biomedical research. So he really has a very unique perspective on properties that are important if we're ever going for the big representation of text. He's uniquely tall, and maybe unique in this room, because other than Fred Jelinek, I think they're the only two with a Wikipedia entry that they may not be aware of. It's my great pleasure.
Thanks, Louise. A little too gracious introduction, but I'll take it when I can get it. What I want to talk about today is something which I've been thinking about for a while, and have kind of been sort of stimulated to talk about it more structurally and formally by a talk that Ed Hovey gave at LREC, a keynote on the role of annotation in our field, particularly something that he frames and other people are also starting to frame as annotation science, or the science of annotation. And so what I want to talk about today to this community, the major issue is, what is the goal of annotation in computational linguistics generally. I'm going to review some methodological assumptions which I think we should pursue, and believe that they guide my own research and my group's work, and that a case study of TimeML will be an example of these methodological assumptions. So I'll talk about that as a case study. Then I'll get to the inadequacies of a specific individual framework or theory, and why, in order to capture the larger picture, reading, story understanding, and other things such as Ed was talking about in the first address on Tuesday, why we need to actually create a unified linguistic annotation of some sort. And then I'll conclude. So what I mean by annotation is, specifically for the context of today, I'm going to focus on mostly semantic annotation. Now, we're familiar with annotation in the context of features that we'll use for any number of applications in computational linguistics: part-of-speech tagging, named entity tagging, for creating labels and tags for various types of document retrieval and clustering. Let's just focus on a couple here, just to give you a sense of where I'm coming from. I'd like to look at examples of semantic annotation, such as predicates or verbs, and their sort of is that okay? Looks like a little bit of distortion. Is it? I don't know if that's, as long as it's readable. Predicates and their arguments. Here, essentially classic named thematic roles or case roles to a predicate. That's a particular kind of semantic annotation task. Anaphors and antecedents, both for objects, entities, as well as for, let's say, facts, propositions, and events. They're all distinct types of anaphor-antecedent links. The annotation effort that goes into creating a corpus associated with this is, in fact, distinct from those related to predicates and arguments. Acronyms and abbreviations and their long forms, such as in bioinformatics, you have an acronym or an abbreviation, and then the long form or the interpretation of what it is. This is a huge area, something I've done work on in the past. And then semantic typing of entities to predicates, such as what actually is the type of an argument that a predicate selects. For example, in work that Patrick's been doing, Patrick Hanks, the man fired the gun. This is distinct from case role assignment. So these are different types of annotations. So I'd like to make a couple of points. One, semantic annotation, I believe, is critical for robust language understanding, and I'll try to argue why. Summarization, question answering, text inferencing, reading, as Ed was talking about, and story understanding more broadly are just some of the examples, major examples in the field right now, mostly pursued through statistical techniques. But I believe semantic annotation is absolutely necessary in order to get to performance that is acceptable. The annotation schemata that we're adopting, I believe, should focus on single coherent themes. That different linguistic phenomena, such as the ones I just mentioned, and others, including such as maybe even WH binding or other types of linguistic effects that you can model, should be annotated separately over the same corpus. That's something I'm going to argue for. And it will guide our research. Annotations, however, if that's the case, then have to be consistent with each other, and that requires a unification and a merging of these multiple annotations in order to come up with an annotation of a specific corpus that is useful for training and then testing applications that are more robust than any particular single annotation scheme would give rise to. So hence, I think the takeaway point I'd like to push is that the annotate, train, and test model, which is part of our field, advances linguistic theory in a way that we don't really appreciate, and in fact isn't necessarily even employed necessarily. Theories need testing to evaluate the coverage and the predictive force. And semantic theories in particular are too complex currently to develop without this model of annotate, train, and test. I think my computer just went to sleep. Okay. So the methodological assumptions that we make as a discipline, and I'm just going to make more explicit, this is my perspective, you may not share this completely, is that we have an annotation scheme to do some sort of annotation, a tagging of a text for subsequent purposes of training algorithms and testing them. This assumes a specific feature set. Now, that feature set is actually an encoding of specific structural descriptions and properties of input data. Now, these structural descriptions are themselves theoretically informed attributes which are derived from empirical observations over the data. Sometimes empirical observations and the theoretical constructions over those observations that go back 70 years, let's say. In the case of the structural properties that we use for annotating for finite state parsing, for example, named entity recognition, the tag set, the phrase set, the types of dependencies you get, such in dependency grammar, these observations go back 40, 50 years. It's not just a feature. It's encapsulating theory. So what you really have is this chain of development. Theory gives rise to this description, which is encodable as features, which themselves are still quite transparently related to the theory. But the annotation is not necessarily itself such a reflection of the theory itself, but if you look at the chain, it is. Now, what I want to argue is that when you do an annotation and put it into that annotate, train, test cycle, the cycle means that that's going to influence your theory. And the theory will change. That's the goal. That's what you want in terms of creating something that we could be proud of as a type of normal scientific behavior in the way that we actually create models of language, which is not part of the pure algebraic theoretical approach, of the classic Chomskyan model, where there is no such integration with real data and the modification of theories from annotation. So to test this example, this methodology, I want to look first at the issue of temporal awareness or temporal information that's associated with language. In particular, I'm going to look at textual input. But the same remarks would go for speech, but that adds a new dimension of complexity. So you take a text such as this Associated Press newswire from '90. This is Gulf War I, with Bush won and Saddam won. And you look at this text, and in order to be able to ask questions, to answer questions that you may have about the events that are going on here, what events actually happened, what events happened before other events, what was the state of, let's say, a particular force relative to another force, or when something happened and some sort of negotiations were being sought. What was the situation on the ground in Iraq, for example? And it's impossible to answer such questions and make such inferences without understanding the relationship that, for example, here in this text, are actually quite explicit, and we understand as readers of a language, of our native language, or if you understand English. But it's quite different than just spotting named entities that would be events, such as, I know a quarantine is an event. Well, here, I see that I'm actually extending a quarantine, and extending is going to essentially give us the information that this quarantine exists. So it's a kind of presupposition being imposed by that particular predicate. One example. So there are events. There are events that didn't happen. There are events that we would like to happen. There are events that happened that we didn't want to happen. And all of these things have different modal status. And they impact the way you would summarize a text. They impact how you would reason about it, how you would answer questions about it. So one thing that we've developed in the context initially of a question answering effort in the United States funded by ARDA, ARDA, starting in 2002, is a time markup language that I call TimeML, starting back in 2002. And this was a markup language that we wanted to mark up not just time expressions, like the ACE-based TimeX2, or not just events, such as just predicates by themselves, but time expressions, anything that could be considered an eventuality, the relations between them, and then such as temporal relations, other relations. And then to put this into, this is essentially to try to encode the best feature set from the theoretical observations that have been made about tense, aspect, temporal relations, temporal ordering for the last 40 years in the field, and then create a specification that we could use to annotate text and then train and create automatic annotators. So this is an instantiation of that chain that I was outlining in the first couple of slides. So, to wit, TimeML 1.2 is the current instantiation of this, which is always in flux, and it essentially allows us to incorporate all those features that I just outlined that I'll go into some detail about, and in fact has just recently been adopted at the Beijing meeting of the ISO, the International Standards Organization, as actually an ISO standard for representing events and times, something we're quite proud of because it's quite an international effort that we've put into that. So the goal here is to show how theory has turned into a more tangible description that we can put into features that are then amenable to the computational cycle that we know and love and has a certain kind of currency in the current field, namely annotation, train, and test. So with that in mind, let me just tell you what TimeML essentially tries to capture in terms of its feature set. I'll go into the recognizers for those. I'll go into some specific problems. And then I will talk about the successes, what we can do, and then I'll talk about what is near to impossible given our current understanding of discourse models and semantics. And then I'll go into how we need unified representations. That's kind of where I'm heading. TimeML encodes any kind of temporal expression. in a text. Dates, times, things that would be called temporal functions, which are relative expressions that don't have any fixed temporal interpretation. Anchors to other events, so such as 3 years after the Gulf War. Well, I don't know when the Gulf War is, but if you can determine when the Gulf War is, then it was 3 years after that. So these kind of relative expressions. It identifies anything that would be a temporal signal relating to events, such as temporal connectives, temporal prepositions, and then any type of event expression very broadly construed. So any verb form in infinitival or tensed form, state of adjectives, event nominals, which are difficult, of course, as you might imagine, to recognize, a merger, the Gulf War, the treaty, the military operation. These are ambiguous, right? Many of these are polysemous objects. The treaty could be the informational or the paper material, but it's also the event that went on. So you have to be able to recognize contexts for when something's an event. Most importantly, for the type of reasoning we want to do, is we want to create dependencies between these time-dependent objects. Anchoring. I want to say that the leaving happened inside Monday. That it's my computer, it's very tired. It was up late. Orderings. The party happened after midnight. And embeddings. John said, Mary left. The leaving is sequenced temporally to the saying. There's a lot of work that's been done on that in semantics and tense processing that we should take advantage of. So just to understand a simple narrative, such as, yesterday Holly was running a marathon when she twisted her ankle, David had pushed her. What we understand to process the temporal aspects of this text are essentially things including time, the notion of an event, such as maybe a transition or accomplished achievements. So you have these kind of lexical aspectual classes, such as Wendler. I have activities or processes, and I have states that persist that may be of interest to me. Then I want to anchor them if I have temporal expressions, and then I want to order them. And the ordering is going to give me something that then I can perhaps apply some sort of closure to create a kind of consistent temporal model of my text. So what I have here now, and what we understand using not just temporal information, but also common sense knowledge, is that I could answer these following questions. When did it occur? The running, February 17th. When did the twisting occur? During the running. Did the pushing occur before the twisting? Yes, we know that because of the way the past perfect gives us that information. If you understand the past perfect, that's what you understand. It's a temporal transformation. Did Holly keep running after twisting her ankle? That's not a temporal fact. That's a common sense fact that you would have to determine from another knowledge source. So even here, even if you could do the temporal information completely, there's still questions that seem temporally related, but you're not going to be able to answer without having common sense knowledge. So there's a lot of applications to having an ability to do temporal awareness of texts, hence the interest in this as a robust application. And I emphasize robust. We need to make these applications robust. Namely, chronological summaries. Biographies have been a very interesting part of the field, but creating coherent, intelligent biographies has been quite a difficult thing. History of patient symptoms. This is a real hot area in biomedical applications to essentially look over discharge summaries of patients and come up with the temporal map or a chronology of an illness of a patient, and then take all those data once they're encoded as features. Then you, if you're doing clustering or, say, disease tracking, they're just features for you. You don't care that there was a theoretical model behind it. They're features. You can go and study the outbreak of SARS or something by virtue of having these new forms of data. So it's data integration. Question answering, that's an obvious first place where this could have an impact. Hence the funders. ARDA has been interested in this. Now NSF is interested in various aspects of annotating to improve question answering. So, but there's a lot of different notions of event in the field. And what we should first do is point out that this is different than topic detection. which has been a big part of DARPA-funded research. And topic detection means I want to find an article about processors, about terrorism, or about something else. And there's a well-defined subject for searching. You have document or collection level search, and a lot of this is essentially to create tagging, schemes for tagging events and maybe nouns that are also events, and then putting them into classifier systems such as Louise was talking about yesterday. There's also classically, from the early 90s, template matching events, structures with slots for participants for the entities, such as these were typically done in the context, again, funded by DARPA. They were very interested at the time in South American terrorist activities. So you've got terrorist activities, or you've got joint ventures, or you've got some sort of event. We're going to take a broad notion of just mention, which is the linguistic expression that expresses an underlying event. Be as close to the text as possible. No abstraction for a particular domain. This will subsume all the other uses, however, because you can just take a small subset to use for your particular application. So there's a classic example of the tipster application. I have a text, and then essentially you have to fill with named entities and events this tie-up relationship, which is a particular kind of joint venture, and so on and so forth. Okay, and at the time, back in the mid-90s, systems could reach 60% accuracy from news articles, and this is what the muck competition pursued after tipster stopped. And there's similar types of evaluations that started with early Trek work before they took Trek started different types of competitions. Now, ACE is another type of event definition, and this is funded to look at a very small set of event types, such as something being destroyed or damaged, something being created, someone giving something to someone else, someone moving, and then interacting. Okay, very, very closely defined event types. And there's these roles for them. The filler of the cause would be an agent, and so on and so forth. Okay? These are very specifically defined. In TimeML, as I mentioned before, we're taking the mention. It's a linguistic expression in the text. It's phrase level. It's going to be a verb or a noun. It could be an adjective in an adjectival expression, such as passengers on board the plane, for example. So that on board is a state that the passengers are predicated of. And since they correspond to surface mentions, it's easier to annotate. It's easier to recognize with automatic recognizers. So the accuracy for this small component is over 82% on our current system, which we call Tarski, which is Temporal Awareness and Reasoning Systems for Question Interpretation. And you can go to tarski.org if you're interested. Like templates, they're going to be linked to times if you can link them. But unlike templates, the times are going to be resolved, and the events are ordered relative to each other. In these other applications, you just extract stuff. Okay? They're events. They may have happened. They may not have happened. And they're not ordered relative to each other. Here we try to create a consistent ordering of everything in a document relative to other events. And the other thing is that, as you'll see, they involve other types of logical relations, which are important for creating this modal aspect of events, something that in the literature is called subordination and aspect, and we're going to call those as well. So I gave you some ideas about what kinds of events we have, what kinds of anchorings and dependencies there are, and here's just a couple of examples. Again, the kinds of things, this is sort of a pseudo-logical form, if you will, that would be, I think the consumer would be, let's say, the reading system that Ed is developing at ISI. One of my colleagues is Jerry Hobbs, who's also Ed's colleague, and so we work carefully to try to make translations from our annotations to first-order expressions in DAML and AL languages that they can use and consume for whatever purpose they want. You have embedding. As I said before, sequence of tense phenomena in different languages behave differently. We need to encode that in our specification. So the teaching happened before the saying. And ordering, John taught after his coffee break. Again, after is an explicit signal of an ordering relationship. So what we encode from the theory, just to get back to this theory to description to features to annotation, is the following. We're obviously interested in anything expressing tense and all aspects of tense. And we're interested in a way of encoding aspect. So tense and aspect are very rich attributes in the annotation of a particular mention of an event in a text. So Reichenbach's view on how you have points of reference to an event relative to the speech time, for example, is encoded as features of aspect in our model. For example, I had mailed the letter when John came. Okay? The had mailed, the mailing is something that's happening before John came. And that's signaled by the mention of a perfect, past perfect here, which essentially creates this flip. Now, can we create an annotated corpus where the verb complex is annotated, put that into a large gold standard corpus such that I can train on it, and then test over free text and accurately get these types of sequences, past tense, past perfect, such that I always get the second sentence happening before the first sentence. Those are the kinds of experiments you want to do on very, very trivial temporal sequencing, and that's what we have been doing. So another important part is grammatical aspect, which is Aktionsarten to the German linguistic community, where you want to be able to integrate the notion of perfective and imperfective to the kind of event that you're actually talking about. So if I have John was running, then John had run some. If John was building a house, I'm just talking about the inside phase of building the house, and the house isn't built. This is not just linguistic and semantic fun. These are important descriptions to then create features from, because inferences are extremely sensitive to such statements in text. We need to make such inferences explicit in order to do better, for example, on the text entailment task that was talked about and mentioned during Ed's talk. So these are things that need to be encoded. Then, from a different tradition, from AI and from temporal logic, we encode the temporal relations of James Allen. It's not James Allen's encoding relations, it's the way he talked about them in their mapping to language. So essentially I have two intervals, and I want to relate intervals to each other, and there's 13 relations. These are going to be values of an attribute that will be in this ordering data structure that we're going to annotate. Okay, now going back to this text, I can pick out temporal expressions. What I understand is that today is going to be linked to those to the document time. I have all these events. Can you see the red? I hope it's readable. These are all different events in the text. There's a lot of events here. Now, and then there are links which are not in the text. They're like phrase structure non-terminals. They're non-consuming tags, if you will. You have to create links. Okay? Links are the three types: temporal relations, aspectual relations, and subordinating relations. I've talked about time and the orderings a la Allen. Aspectual relations are going to be phases, okay, brought about by aspect markers in a language. Explicit lexical items, which are free morphemes, or bound aspectual terms in languages, I believe, such as Czech. Subordinating relations are going to be those which subordinate other events, and those are going to be reporting verbs, such as it was reported that, or Mary said, belief contexts, presuppositions, such as regret things. These are not just idle theoretical speculations, but have very important consequences. So I have things happening at the same time. I have identity. Drive and drove are identical events. John drove to Boston. During his drive, he ate a donut. I want to annotate the events. Here's a case of the task of doing temporal annotation incorporating one aspect of anaphora that I mentioned earlier in terms of semantic annotation. This is not anaphora as much as identity. That drive and the driving event here are identical. For most of the murder suspects, suspects have already been arrested. Okay? The murders happened before the arresting. Okay? So that's a before relationship. I took sort of unusual examples. These are from the text that we have. And then you have the inverse for all of these. You have immediately before, which is a meet before relationship in temporal logic. So all passengers died when the plane crashed. It's kind of a gruesome example, thanks to Rob Gazauskis and Andrea Zetzer. The crashing gives rise to a meet of the event of dying and subsequent states of being dead, and so on and so forth. Arriving is happening inside Thursday, including the inverse. The during is kind of like James Allen's hold, for 20 minutes, okay? And then beginning, 6 o'clock is the beginning of this state of being in the gym, and 7 o'clock is the end of being in the gym, okay? Now, there's any number of ways of annotating the temporal relationships, and we've played with a lot of them. And it's the question of what gives rise to the best inter-annotator agreement. And that's a very important part. It's what looks best theoretically is very often not the best way to annotate something, because you want to give rise to good inter-annotator scoring so that you can create a good corpus that is then amenable to the cycle, okay, of annotate and train and test. So these are linked to times, the todays. The Tuesday is going to be, by virtue of this past tense, we understand it to be the previous Tuesday, even though Tuesday could be the future Tuesday if it said President Bush on Tuesday will announce. That's going to be the upcoming Tuesday. So even Tempex and recognizers in turn recognize based on local features, and that's just a feature set of what's the tense of the verb to my left or to my right or in my offset. And you can determine whether it's a future interpretation of Tuesday or the most approximate previous Tuesday. So you don't need a lot of theory to do some of these. For some of them you do, however. So here I have anchoring, which means putting a temporal relation of an event relative to a time expression. So the seeking of peace is today. Is there peace today? No, you're seeking peace, but the seeking's today. The arriving is today. The saying is Tuesday, and so on and so forth. So you annotate these. You want to be able to automatically recognize this. Ordering, even for humans, is the most difficult task. Temporal ordering is extremely hard because on real text, not just sort of simple children's stories, which I'll give an example of later, there's a style that is imposed or is assumed by the author, and you're not there as an author to make a narrative of exactly the sequence of events. You can't even do it because you have so many subordinations of modality, and you're basically talking about things which are put there because of considerations of topic and theme and other pragmatic concerns. Those things get in the way of processors which are trying to linearize the events. But that's the way we talk, so we got to deal with it. And the way to deal with that is to break the problem down and see what we can do on simple models and then create more and more complex models of temporal ordering. So this is just 1/10 of the orderings. As the author, who was it the other day? Peter mentioned the number of orderings in any text is quadratic to the number of temporally sensitive objects, events, and time expressions. So it's large. Aspectual links is going to be a relationship that we create for looking at phases. Okay? I want to mark these up, starting to read, finishing the table, stopping talking, keeping talking. Okay? This is something that is important for inference. And they happen in text. Not always with verbs, sometimes with nominalized nouns or nouns that are events. So the build-up is continuing. Okay? The withdrawal is beginning. Those are the only two examples in this text. And now subordination links. This is something which relates to a lot of other problems and a lot of other areas of interest in contemporary inference, computational linguistics, such as text entailment. What we are trying to do with this is to create the modal context the modal envelope, if you will, or wrapper of events, because those are going to be the determinants for what you can say about that event in a temporal inference system later on. So here, a factive will basically let this event be safe for subsequent inferencing. This happened. Okay? Marrying John is an event also that happened. Counterfactives, this buying wine did not happen. Okay? Forget the presuppositions of, I meant to and all that stuff. That's very interesting, but we're just looking at whether the event happened. So that buying did not happen. Notice that any event extraction system is just going to say there's a wine buying. Well, no, there was no wine buying. There was a forgetting, and there was no wine buying at all in that case. Obviously, tense and infinitival parsing is important, as we're well aware of, and so on and so forth. The divorce did not happen. It was prevented. Okay, the accident was prevented, or the explosion was stopped. These are all going to take away the existence, and then negations of events are also quite difficult to handle, but we need to annotate those so that we can then reason appropriately with them. Okay, so we want, as readers and annotators, we need to annotate such things. This withdrawal didn't happen. This quarantine is already existing, and we're extending it. Mediating is something that is being sought, and the crisis here is actually something that, again, has a kind of presupposition of existing. So in the text, you can actually create quite a bit of information as to what events are happening before other events, but you need to have the subordination information. And finally, reporting. Okay, let's talk a little bit about the parsing. So I've done human annotation. How good can annotation and recognizing algorithms be for finding the temporal structure in a text? So I'm going to call TimeML parsing the automatic detection of temporal structure in a text. Don't look at this. I just have this to show that we've modularized the system according to the strategy that I've talked about in the first few slides. We're compartmentalizing the tasks, and it's something that, of course, just good engineering and software development would suggest you do in any case. But it's also something that I believe is a good strategy for us to pursue for turning theory into annotation, and then for computational models, which then influence the theory. All right, so I'm going to talk a little bit about these devices, and then the temporal parsing is something I'm going to have as an example and a demo of. How good a parsing is it? And that's just the internals of this, which combine rule-based and machine learning classifiers. There's several articles. You can go to the website. Coling presentation that Inderjeet Mani and I gave in Sydney a couple of months ago on this. So time expression parsing finds all of these things in text, and these do pretty well. Doing well means to find the extent, as in any named entity problem, but also to give the appropriate interpretation if you have one. So if you have Monday, you can find the extent of Monday. That wouldn't be a hard problem. That's just lexical lookup. But you want to give the actual value. Okay. 3 months, you want to give the ISO value for what 3 months would be. Every month, you need some sort of attribute structure which gives then rise to a quantificational structure in something like DAML or ALTime, for example. I'm not going to talk about that. The performance is quite good. You get 87 to 88% accuracy on that. And the details I'm not going to talk about right now, but I can give you F measures on various corpora if you're interested. Oh my God, 5 minutes? Are you sure? Really? 10 minutes maybe? So you have event parsing. This is better than I was hoping. I had originally 145 slides and pruned it to 70. So finding events is also something which is quite accurate. Given that we're looking at the textual extent and looking at it quite broadly, we're not looking at just bombings or just kidnappings or something like that. And what we've done essentially is to take the theoretical advances and incorporate them as features. And I'm not going to go into the details. This also is outlined in 2 LREC papers and a FLAIR paper. There's plenty of stuff to read on this. The evaluations on this, measured against TimeBank, gives rise to fairly good results. It's a small corpus to train on, but the fact is that this is also with the attributes which are of importance for doing subsequent inference, such as whether or not it's in the context of a negation, saw or did not see, aspect, modality in the context of a modal such as should or could, what tense it is, whether it's actually occurring as a noun or an event, noun or a verb, and then the class, whether it's an aspect verb, what kind of aspectual class it is. Okay, now, temporal relation. And I want to just get to this so I can go to this demo and then try to have some kind of closure. There's two sorts of temporal parsing. There's lexically driven parsing, and there's discourse-based parsing. This is the way the field, this is the way we're going to pursue this, and we have to, because this is all we know about it. If you just throw everything into, as features, into Maxent classification, without having the features being derived from a model, you don't get very good results at all. So subordinating links, as I told you already, are those things which give rise to these very important modal contexts. Okay? And Slinkit is a program we have developed that's downloadable for recognizing those contexts and creating the annotation for those. And that's quite good, not surprisingly, because it's lexically based, and if you've got the lexicon pretty determined and you have the features encoded, it's going to perform pretty well. The hard part is inferring temporal relations. I had mailed the letter when John came. I told you about that one already. Simpson made the call at 3. Later, he was spotted driving towards Westwood. Sound familiar? These are after relationships. There's an after relationship here. Max entered the room. Mary stood up. Max fell. John pushed him. That's a kind of explanation. These are very difficult things to get unless you've trained on corpora that have such information. Having corpora like this is going to be it's going to be very sparse in terms of the data, and so on and so forth. That's the kind of relationships we're trying to discover. I'm going to go through this very quickly in the interest of, well, in my interest and your time. The TimeML corpora, just in terms of how it breaks down into features, is really already in terms of relations, that's not very good inter-annotator reliability on the TimeBank 1.2. We're improving, and we're hoping to get much higher inter-annotator scoring on the basis of new guidelines that we've learned from the low scoring and the low performance on the temporal processing. And we have some very good ideas for how to actually improve that. TimeML 1.3 will have, I believe, considerably higher intercoding scoring. The features that we use for learning very quickly are what you might expect: modality, negation, presence, where something might occur relative to the signals in the text. And what is interesting is that, from a baseline, the event time linking, for example, such as the party on Tuesday or saying on Tuesday or something, is not bad. But it's not really clear that this is due to the Maxent classifier itself, or just due to the kind of skewing and the bias of the data on certain types of relations. Now, let me look at, do I have 5 minutes? Okay. Or let me just get to the point of the ordering of events. In the interest of actually making some progress over discourse relations and temporal relations, the hardest problem, temporal ordering, what we've done is created what I call a developmental corpus of stories. And we've collected texts from kindergarten to 5th grade, reading curriculum. And I have partitioned them according to only a couple of features: tense, aspect, and other types of features which are TimeML features. Is there sequence of tense? Is there subordination? And so on and so forth. And then model geared towards homeschooling in the United States, of which there are a lot. David wants to buy a Christmas present, yada, yada, yada. Notice the narrative present. Notice also that this is very simple to understand. You have stage setting in kind of stative. Then you have a sequence of events. Occasionally you jump out with some more stage setting. The only time you violate the narrative order, right, a la Dowdy and other people who've done discourse, is that when his mother opens the present, she screams because she sees a spider. That inverts the narrative order. Okay, That's the only inversion right here. Now, so using basically an encoding of temporal discourse interpretation principle of Dowdy and Comp and Riley's discourse way of what progresses the text, we're going to encode this and then put this into the parser to see what kind of structure we get. This is the text we want, and I will show you just that it actually does what I say on this type of example. So I'm going to this is a demo you can get to from the web. I'm going to take the text in phase 2 of kindergarten, where you can actually use past tense. So that's the text that I just showed you, and I'm going to put it in as user input. So David wanted to buy something, yada, 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 okay? And hopefully this won't crash. So I'm going to parse it with the named entities, which are the times and the events. And then if there's any modality, it'll create those. So those are events with the feature structures. And here's the temporal expressions that are seen in the text, okay? So I've essentially reified all the events. Okay, that's fairly straightforward. Now, the temporal ordering, I just want to show you that we can actually get this, but this is a very simple example. So this is Tango, which is a visual browser for events and also for annotating. And once you see this, okay, it's very much like Callisto or Gate sort of structures. You've got the text up here. It's used for annotation, but you can also display things. So I'm going to arrange these events. Okay, and this is the temporal ordering. If you look at these are the temporal orderings that have been discovered. These are all different events in red. You can't read them. I'm just giving you an idea of what's going on here. If I want to see the ordering of things relative to each other. Now, we have a visual display which is consistent, which is satisfiable with the temporal relations that have been structured, usually a little bit easier to read. But given the way this works, and I'll just conclude in 3 minutes, if I can have 3 minutes. The narrative convention here is what's allowing for closure, transitive closure, to essentially inform me that this sequence of events of A happening before B, happening before C, and A happening before C is consistent. That's satisfiable. And that's not typically the case. If I break out of this convention, even a little bit, then all hell breaks loose, because we don't have the data. We don't have a theory of discourse to understand how to actually do such modeling. So we have an annotate, train, and test model. But on top of that, I've proposed that we do modeling to analyze the data using theoretical preconceptions in addition to that, which then give rise to this cycle that is so useful. An annotation scheme should cover one coherent phenomenon. The linguistic phenomena are separable, and therefore so are their features. The attributes and the rules relating them are going to be modular. So if their features are separable, then so are their recognizers. Parsers and classifiers can be developed to identify this subset. This model, annotate, train, and test paradigm allows you to create easier annotation and training and testing of these single linguistic phenomena. Okay, now I'm just going to go directly to the conclusion. This is part of a larger problem, a larger project, taking our annotation and this whole methodology, which I'm pursuing with the team of Martha Palmer, Adam Myers, Jan Wiebe, and Mitch Marcus, to integrate, and also working actually closely with Jan Hayek with dependency parsing, dependency structures, to integrate these annotation schemes. I wanted to talk about the methodology here because I thought that was important to motivate that we need integration. Let me just conclude. You probably have questions. I'm okay? Well, then I'll just talk about the phenomena that are being approached. So syntactic structures, clearly, predicate argument structure from PropBank, temporal structure, which we already talked about, and then emotive and discourse structure, which comes from this opinion corpus of Jan Wiebe. Now, we don't have theories, worked out theories for a lot of these structures. We don't have the temporal ordering and how it relates to discourse. We just don't have the semantic theories for those things. Discourse structure, we have a lot of proposals, and it's important to try to encode those, the pragmatic influences of text, of discourse, and of rhetorical relations, encode those, put them into the paradigm and test them, and improve the theory. That will be the testing of a theory. So just to conclude, Descriptions of semantic phenomena in language must continue to be developed as our theories of them are still inadequate. Perhaps that's just a given, but I think that if we take this paradigm, the linguistic phenomena can be investigated separately, then appropriate theories will follow. But not abstract theoretical algebraic work, as in conventional linguistics. That's dead. It's not going to work. You need to test it. You need to test it on data and do this cycle. There are a lot of areas that are intractable. What's interesting is what's not intractable, but what's actually quite tractable. Temporal ordering in these cases of very well-behaved models, such as simple narratives, simple biographies. Parsing discourse relations is extremely difficult, and we've tried to integrate knowledge sources for that, and I can give you a pointer to some of the work that we've done on that. So just to conclude, the model, annotate, train, and test, and refine paradigm is useful, if not necessary, for developing more robust semantic theories and systems. Thanks for your time. Just want to mention this is a fairly large group of people who've helped develop TimeML as well as Tarski, and I just wanted to thank those individuals. The development of TimeML has been an international pursuit over the last 4 years, and it's in fact just a little plug. I'm creating a multilingual working group of TimeML to annotate 25 different languages of the same text to see where it's deficient and where it needs improvement so that we can do coverage of that. Okay?
Any questions?
Yes, Fred.
If I read it correctly, the inter-annotator agreement is 55%.
That's yes, exactly, of relations with all their attributes, yes.
So,
but that's not surprising given you've got 13 relations to choose from.
How much do you need for it to be used?
I think 80.
And so how are you going to do it?
It's a good question, and we have a plan. Remember that when you're doing the annotation of relations, you're taking this event is rel type X to this event. Well, there's 13 possibilities. So we're going to simplify it to 3 or 4 and use a calculus of neighborhoods to essentially generalize the relationships.
So you don't think you can do it by making a more precise group?
Okay, so that's a good point as well. So first off, we're going to make more underspecified temporal relationships, which is actually fine, because given the context, lexical semantics and other things can actually probably fill in the details. So say 4 relations. That'll simplify the classification task. Secondly, you make a very good point. In the annotation, you want to make clear that the annotators do provide the kinds of links that are then going to be subsequently helpful. You need, for example, a lot of people didn't annotate one sentence to the next in terms of the temporal relationship. Well, that's kind of a no-brainer. One should do that. And so there's 2 ways of pursuing that. We have a graphical annotation that now helps the annotator, sort of forces them to think about the events, the sentences as events next to each other. So you impose that in the guideline, to answer your question. The guideline should be more precise. So the guideline has been rewritten as a result of this scoring and suggestions for how to improve the inter-annotator scoring. And so what we're going to do is we're currently rewriting the guideline, and we're going to re-release a new version of TimeBank 1.2 with that and see what kind of scoring we get.
And how slow will it make it?
How slow will it make the
annotation? I mean, the more precise the guideline, of course, the more they think about it.
Well, we just did an experiment this summer, which was to do just that annotation. Okay, don't think about subordination. Don't think about any of the other relations, not even the events within the sentence. Just take the main predicate. Okay, John arrived, Mary left, Carol, smiled. Okay, and essentially, or had smiled, or whatever. Just ignoring any other events in the text. Just do that single relation on one pass through, and then go next to do a different kind of pass. So even within TimeML, we're taking the annotation in layers, which makes it much easier. And I'd like to hear other people's experience for annotations, such as in the dependency tree bank, and in fact, from your own experience doing a completely different type of data set. Has that proved useful, or is it a different kind of problem that you don't encounter? But the experiment showed that you get really good annotation when you just do one simple type of focus, namely sentence to sentence to sentence to sentence. It's not obviously complete, but it's something that you would then feed in as the first layer to subsequent annotation. Does that make sense? I don't know what.
I ask you how fast you can do it.
Oh, how many articles can you?
How many sentences or how many
For-
words per minute?
Yeah,
of,
for that, the original
session?
annotation was extremely time-consuming. It took that's with time expressions, events, and temporal expressions. It was one article, typical Wall Street Journal and AP, per 2 to 4 hours. Very time-consuming, and then it has to be checked.
Were they doing just time expressions?
No, that was
or
that was
one
everything.
pass And then,
Well, that was with pre-annotation. That was with pre-processing. But we've made it much faster since then. That was with the initial annotation, with TimeML 1.0.
But you have very good inter-annotator agreement on the time expressions.
We do,
The time.
right. And so with the pre-processing, yeah, the big bottleneck is the temporal relations. And this summer, per article, the person who did it was doing one article every 15 minutes. So that's much better because everything was pre-processed. We did all the events and time expressions first. So,
And Ed?
yeah, Ed.
So James, just one quick point and then a comment. In our experience on Ontonodes, by simplifying the annotation down to very elemental steps, we try to make it like 100 sentences, just one elemental decision per half hour.
Mm-hmm.
And then you can get through, say, a 1,000,000-word corpus in 4 years or something. And then you can argue, so it's an interesting question as to where is it better, given how much you want to learn, how complex it is it better to get less data or more
Right.
depth? Or more
So did you do multiple passes through the corpus, or that was just with one specific annotation?
This is 2 annotators doing every noun and every verb.
Doing an ontological classification of them.
Yes, and if there's less than 90% agreement, they go back.
Right,
And we
right.
just do it again until.
Yeah.
Yeah. So the comment is, though, I like very much the way you introduce in this pipeline the modeling phase, because the people who made the theory are some already dead, right?
Yeah,
Reichenbach.
yeah.
So you need a space where you can incorporate different models and create different theories, create a
That's
model
right.
and close the loop.
It's a very good point. The annotation incorporates different theories. Different annotations will, yes.
So inevitably, the model, that which comes out of the model is going to diverge from that which was in the theory.
Yep.
So this is the interface between our field and linguistics or philosophy or wherever.
Yep.
Do you actually find that where these divergences happen, you go back to those communities and say, we computational linguists can teach you something about your things, or don't you do that?
We're trying. Given that, Graham Katz and I have been working on the semantics of TimeML, and Graham has worked on temporal ordering within semantics and aspect issues for quite a while as well. But what's interesting is now we've got, so 2 strains are sort of pushing 2 very good semanticists who've ignored corpus for quite a while. Nicholas Asher, for example, great guy, never really looked at real text until maybe a couple of years ago. He's now annotating an SDRT corpus with the rhetorical relations, inspired by the RST corpus and by GraphBank and by other corpora. And so, as you know, Alex Laskarides has been interested in corpora for quite a while and has gotten more interested in doing larger corpus annotation for purposes of doing the kind of stuff that she's done with Lapata. So your question is still not answered. Has it influenced their theory? I think it will. For one thing, I think the semantics and the semantics of and the number of the rhetorical relations in SDRT is absurdly large, for one thing. And I think it's far too lexically based and is something that is perhaps part of a different logic. I think they're going to have difficulty getting good inter-annotator scoring. We've found already using Hobbes's relations that where the difficulty, this is an experiment we did to see how good discourse parsing is. And for Hobbes's, which is what, to a large extent, Asher and Laskarides take a lot of their ideas from Jerry's 87 work on discourse relations. You get really good agreement, except on the explain and elaborate relationships in the corpus. It's a very subjective thing. Does this really explain that? Is this an elaboration of that? It's subjective. The ones that are really good are Interestingly, things that are very syntactically tight and bound, contrast, parallel structures, other people can say more about this than myself. And those are really good for scoring, and hence we do really well with those. So I think it will influence the theory. I hope it does. That's what my hope is.
One more question?
Well, just a short question. You said that temporal relations are very difficult to mark or to annotate. How is it with the event identification? I mean, with the identification of which mention or expression identifies an event?
Which mention?
Yeah, well, if you just don't go predicate by predicate, but if you also accept that some nouns, surface nouns, may identify an event, how the annotators agree on that?
That's a very good question. The annotator scoring for event annotation is lowest on nominals that are not derived from verbs. So, yes. So you have some cases which are unambiguous, such as party, right? But my favorite kinds of examples are polysemous objects, right? So the Parisian regular polysomy cases, such as lecture or Birovish's university. These are events in cases you look at the local context. A lot of people look at coerced local context. It doesn't work. The annotation on that is still quite low. So yeah, that's really an interesting problem, which points out that the theoretical explanations for those is still, it might be good, but it's not translatable into features yet. We don't understand that conversion yet.
Thank you.
Okay, thank you.